Welcome back to more applications with vectors, everyone. Last class, we ended with this application here. And the most important thing is, yes, you know how to calculate. You understand the language of bearing, direction angle, the difference between them. You also know that magnitude always means the speed that it's flying. And once we got the vector of once we got the velocity vector, we have to be able to describe and analyze what it really means, right? What does this 453.15 really telling us? That it's flying east, right? Northward, 211.31 miles per hour and so forth. Okay, you need to be able to communicate that. We're going to take that now and make it more fun. We have an airplane flying. Ba-ba-da-ba. All right, airplane is flying. Let's draw the airplane. The key to success in this problem is drawing the sketch very clean and very organized, okay? So we have an airplane flying. And where is it flying? It's flying some sort of direction, okay? Let's draw the path of the airplane. It says it's flying at a bearing of 170 and 460 miles per hour, which is the magnitude, right? So here's what we're going to do. We're going to draw the path of the airplane. The airplane is flying what? 170 it says, right? 170 bearing, we go this way, right? And I know that's closer to 180, but I'm going to draw it so we have a little bit of space, and you'll see why later. I know that's not exactly 170. That's a pretty bad depiction of 170, but let's just label it 170. The plane has a bearing of 170 degrees, but this is the airplane's bearing, right? Or the airplane's vector. So we're going to go airplane, vector. You see how A stands for airplane in this case? That makes a lot of sense, okay? And you think you know why. And let's label that as 460 miles per hour because that's how it's flying, okay? And you know what? With that piece of information, we know so much more, don't we? We know a lot of other angle information. We know this guy must be 80 degrees. We know this guy must be 10 degrees. Just think about it if you don't get it right now, okay? We also know one more angle. We also know that from this angle all the way this way, all right, to the bearing, it's going to be 280 degrees. It might be helpful to write all this information now before the picture gets a little bit messy. But what happens to the airplane? A few minutes later, the wind is blowing. The wind is blowing where? Wind is blowing at a different bearing of 200 degrees and 80 miles per hour. Luckily, the wind is not as fast as us, right? So wait, but where does the wind hit us, right? We have to understand there's something unique happening here, okay? So this is when my art skills come in, okay? Actually, the wind is hitting at this vector here. We're going to draw a new compass. You see this new compass? This new compass dictates our wind. Because if you think about the plane, it's flying in this direction, right? So if you think about it, it's actually southeast that's flying, okay? But there's a wind. Wind is coming. How fast is it coming? It's coming bearing of 200 degrees. So wait, let's actually sketch the bearing. 200 degrees is a greater than 180. Oh, wait, what happened here? Okay, it's greater than 180 by how much? A little bit. So we're going to draw it there, okay? 200, that means it's 180 plus a little bit more, right? It's 280. Okay, so the wind is blowing this way. Now, how fast is the wind blowing? 80 miles per hour. That's the magnitude of the wind. So I'm going to put 80 miles per hour, and I'm going to go, this is my wind vector. You feel me? Okay? Okay. This with this information, let's write a lot of different angles too. Wait, if I focus in on this, isn't this 20 degrees right here? Let's erase that and write it better because I need you to see this clearly. Isn't this 20 degrees right here? Do you see why? Because this guy traveled 200 degrees, right? Bearing up. That means it's 180 plus 20. That gives you 200. So I'm going to do that right there. What other angles do we know? Of course, we know a lot of different angles, right? We know from here to here then, right? From 0 all the way to here, that direction angle. We know all that information, okay? But that is the path, okay? That's the pretty good picture to start with, and I think you understand what the W vector stands for. Okay, and you see all the angle measurements. Make sure you can see your picture very clearly. It's going to help us later. So what I'm going to do is I'm going to connect the plane and the actual wind, how it's affecting the airplane, right? So I'm going to draw another compass here for later purpose, okay? Later purpose, okay? Okay, now with this, let's start answering the question. We got a perfect picture now, a visual. Now it should make our life much easier, okay? Find the component form of the velocity of the airplane. Component form is basically this right here, the resultant. We're looking for the resultant, okay? So what are we gonna do? We're gonna do part A here together, okay? We know that the airplane has this. 460, right? Times cosine of what angle goes here, and 460 times sine what angle goes here is what I want you to kind of calculate. And then we also have the wind, right? The wind vector is 80 times cosine of what angle? 80 miles per hour times sine of what angle? Okay, think about that. And then turn the video back on, okay? Because remember what we talked about, it's the direction angle, okay? Did you figure it out? Yeah, I hope you didn't write the bearing angle, fool. I hope you wrote 280 degrees here and 280 degrees here because it has to be the direction angle. Then how about for the other guy, the wind, right? The wind has to be from also all the way from, I'll zoom in from here all the way to here, which will make that angle what? I can't hear you. I think I heard 250 though. 250. That's right. It should be 250 degrees here. Now, if you don't understand why that's 250, can you ask me maybe? Or ask your neighbor, okay? And you know what I did? I just punched it in my calculator and here's what I got. I came up with 700. Oh, the vector is 79.878. And it's going to be negative 450.012. We'll discuss all these values in a sec. The winds vector, do you understand what we mean by that, right? Oh, sorry, this guy needs to go here. Sorry, my keyboard moved. Sorry. Now, do you understand what I mean by that, right? It means the airplane's vector, this guy, it's going this direction. The wind vector, it better make sense with this vector here. So let's check that, okay? I noticed that when I'm making these videos, you only see the top of my head, huh? Oh man, that bald spot. Okay, anyways, sorry. Negative 27.362, and I got negative 75.175. That's what I got for the vector. Now, let's see if this makes sense, okay? Let's see. 79.878, that tells you that it's going which direction, right? Is it showing you this value here, right? The airplane. And this guy here, is it showing you that vector? So think about what these are saying, okay? Is it going right? And is it going down, right? Is it going to the left or is it going down is what you have to think about, okay? Okay, so I think these answers make sense. And if you don't, stop the video and ask, okay? So now what is the resultant then, right? What do we mean by the resultant, that word? The resultant is this vector here. Right? That resultant. So where is the airplane after it's been basically pushed by the wind? So, I mean, it's as easy as you think it is. It's airplane plus wind vector.
Something went wrong.
Oh, sorry.
Please try again.
I don't know. I must have said something and then Siri went off. And that equals, ready? We just add it together literally and I get this value. Make sure you're holding the integrity of the values and you're utilizing the whole values, not the rounded values. Again, I'm only going to say this one time ever. Using the integrity of the values, I add this vector and this vector. And here's what I get. I get 52.516. And then I add this, the vertical component and the vertical component here, and here's what I get. I get negative 528.187. So think about it. It's 52.516, which implies that it went to the right? And then it went down. And is that what this resultant is kind of depicting? Okay, think about that. And that is our resultant. And we just answered part A. Find the component form of the velocity of the airplane. Now, the velocity of the airplane now is this. Now, why don't you go ahead and describe what this is saying? It's similar to the description of this guy here, if you think about it. Okay, all right. Now, let's go to the B, part B. Why did it do that? Why is it misbehaving again? Okay, sorry, resultant, okay? Now we're going to go to B, and part B asks for, find the actual ground speed and direction of the plane. Find the actual ground speed and direction of the plane. Now, what does that mean? It's actually so much easier than you think. Actual ground speed and direction of airplane. Okay? Well, we already have the components, right? Don't we already have the components? So speed is what? Is the velocity vector of the resultant, the actual magnitude. So what do we get? This is our A, and let's say this is our W, right? So we're going to go A squared plus W squared, square root that sucker. That's why you need to keep the values in your calculator. Don't forget, okay? You'll get 530, this is an approximation, 530.791, what? Miles per hour. Okay, so think about this question. Did the airplane get faster or did it get slower? Okay, though now you should see that. Okay, now we found the speed, right? Now let's find the direction of the airplane. Direction of the airplane is actually easy too, because all we have to do is tangent inverse of the W. We found the magnitude or the speed of the ground speed of the airplane, right? Because the airplane's here now, because it's been moved by the wind. Now what we need to do is we need to find the direction of. The direction is here, tangent inverse of the wind, the vertical component over the vertical component. And here's what we get. That's weird. I got negative 84.3 degrees. Of course, I rounded to the nearest tenth here. But you remember, I'm just showing you the rounded value, but you have to keep the integrity of the entire value. But wait, that doesn't make any sense. We can't just talk about from here to here like this, right? We need to talk the bearing of. We need the bearing of. So what do we have to do to this guy? So if we're saying direction of the airplane, you need to understand that we're asking about the bearing of the plane. So it's going to be what? It's going to be 90 degrees plus 84.3 degrees. Now, why did I put a quotation around the 84.3 degrees? Because it's not really 84.3 degrees. It's like some long number, right? So in your calculator somewhere, it exists. So it's going to be 174.3. So the airplane is flying at 530.791 miles per hour at the bearing of 174.3. But the 174.3 should already tell you that it's actually flying southeast because it's the bearing from here all the way to here. All right. Good luck, buddies. All right. So I'll write that here. Bearing of. Okay. Bearing of. Okay, good luck. This is not that tricky, right? You understand why it's the resultant, and you see the picture is really important. So if you could draw the picture, you should be in good shape. Try the homework problems, okay? All right, bye.